In this tutorial video, we will be learning on numerical differentiation and gradient method. We will be doing the coding on Google Colab. Like we did in the previous video, we will be starting with the installation of Blueqat. Type the code, !pip install Blueqat in order to install Blueqat. Let us do it in Google Colab. Type the code that was shown earlier. And click on the play button to run the code. Blueqat will be installed after a while. Firstly, what is numerical differentiation? Numerical differentiation is the process of finding the numerical value of a derivative of a given function at a given point. The differential coefficient can be obtained from the function f of x and the minute change h. For example, when f of x is equal to x squared, when x is equal to 1, the differential coefficient when h is equal to 0.1 can be seen on Google Colab. Next, let us see on partial differentiation. In a quantum circuit that includes NISQ parameters, many angles appear as variables in the circuit. Partial differentiation allows you to obtain the derivative for a particular parameter as shown below. Next we will see the slope. The gradient or slope is a vector of this partial derivative as shown below. Since the derivative is 0 in the minimum values, it is necessary to search for the minimum values by updating all partial derivatives using the gradient to find such a place, where e indicates the learning rate as shown in the formula. Now let us learn on SGD, which means stochastic gradient descent, probabilistically, which select samples to perform gradient calculations. Immediately, we will try VQE to find the minimum expected value of the measured value in the circuit using the RY gate. Now let us check another simple circuit with X measurement. For that, install the library. Then next, type the codes as shown below, in which, the first method is the expected value of ZAT. Next, we will be initializing the setting. Then, updating and recording the gradients. Then, assigning the final value and plotting the expected value. After running the code, VQE was completed safely. Next, let us see on loss function. The VQE needs to learn the variational principle, so let us use the loss function. This can be remembered as machine learning. Type the code. The first method is used for expected value. Then, the method used for loss function. Followed by, the method used for differential coefficient, and then the method used for assigning the slope. Then, initializing and plotting the loss function. After running the code, we will get the expected value and the loss function. Next, let us see on momentum stochastic gradient descent probabilistically, which selects samples to perform gradient calculations. Type the code. The first method is used for updating all partial derivatives using the gradient using the momentum stochastic gradient descent. Then, initialization of parameters. Next, plotting the momentum stochastic gradient descent and the loss function. After running the code, we will get the loss function for every momentum stochastic gradient descent probabilistic. Finally, let us see on adaptive gradient, which adapts the learning rate to the parameters, performing smaller updates, that is, low learning rates for parameters associated with frequently occurring features, and larger updates, that is, high learning rates for parameters associated with infrequent features. For that, type the code. The first method is used for defining and performing updates of the adaptive gradient with the parameters. Then, initialization of parameters and constants. Next, plotting the adaptive gradient and the loss function. After running the code, we will get the adaptive gradient performing updates with loss function. Thank you for watching this video.